Good morning, good evening, good afternoon, depending on where you are. Today is May 22nd, and this is another installment of Batch Working Group meeting. My name is Mate, and I'll be your host today. We have one topic from Ally, so take it away from here, Ally.
Sure. Thank you, Mache. Can you guys see my screen?
Yes, we can see your cap and the PR that you have open.
Okay, perfect. So for today, in the last meeting, I received some feedback, and today I wanted to share some explorations I have done regarding that. So one of the um, questions that was raised was, can we explore moving the definition of device mapping in this gap from cluster queue to resource flavor? And as part of today's discussion, I wanted to share some ideas on what it would look like first, and then follow it up with some problematic scenarios that I came across while brainstorming this. So let me get started with how moving the device mapping into resource flavors will look like. I'm scrolling down the cap, and I see a hand raised.
Uh, yes, can you possibly make the window a little bit smaller so the font is eventually larger on the screen? It's quite too hard to read what you're presenting.
Oh, okay. I have a better idea. Let me open this as a file so it will.
Okay, maybe yeah, that's better. Thanks.
Okay, perfect. And let me find where I was at. Uh, okay, so yeah, we were here. Okay, so moving this to resource flavor, I've introduced a field called dynamic resources in the resource flavor, which is a list of dynamic resource mapping. And the mapping struct here, it includes a name. This will be the canonical name of this resource, and then list of device class names. Um, this is exactly similar to how we had it in cluster queue, except there is going to be one indirection involved here, where the name is defined in the resource flavor, and then this name will be used in cluster queue to define quota. And I have an example of how to do this. So this is the modified resource flavor with dynamic resources. And we have two canonical names here, whole GPUs and shared GPUs. And then the whole GPUs has a device class name called gpu.example.com, and shared GPUs has time shared and space shared. I have a type here. Excuse me. Now, with the shared, so given these two canonical names, in the cluster queue, we have nominal quota defined with whole GPUs and shared GPUs. And obviously, because they are being used here, they need to be also included in the covered resources list. So I want to take a pause here. I wanted to get the maintainer's thoughts on whether this was the right or intended direction where we wanted to go when moving this mapping over. Yeah, can go ahead, Marcin.
Okay, so I was probably like the person who asked it in the review. So yeah, that's something that I wanted to see. It seems to match my original idea, but I would like other maintainers to express their opinion before giving LGTM or whatever. Do we have anyone? As we have Yuki and we have Michał.
Okay, can you hear me?
Hold on, Michał. Yuki has raised his hand first. So I'll let him speak first.
Okay, thank you. Okay, so I can take. So can you hear me?
Yep.
Yep.
Thank you for progressing this effort. First of all, as I mentioned in this cap comment, so I am wondering if we really want to modify this device class name and resource name mapping dynamically in resource flavor resource. So I mean, can we just add the resource device class name and the resource name mapping in the cluster scope queue configuration API? In that case, we do not need to consider resource mapping every for queue resources. For example, we have cluster queue and cohort or something else resources which has resource name fields. In this resource flavor design, if we accept this resource design definition, maybe we need to have something transformations mechanism from resource flavor resource mapping every for resources for like cost cluster queue and cohort resources, right? This is my questions.
So let me try to summarize what you're recommending. So you're saying that we need to have a separate cluster scope CR that defines this mapping and then embed it in resource flavor or cluster queue wherever it is needed. Is that how you're envisioning this?
Actually, so we already have queue configuration API. So I do not mean new custom resource.
Okay.
Yep.
But does that configuration API is that a runtime thing? So for example, if we want to change the mapping, do we have to restart the queue controller or can it dynamically change can it dynamically get the changed configuration?
Yeah, I think that is one problem. Actually, so we have similar mechanism for resource transformation feature in queue already. So yeah, actually, so currently I cannot go ahead, Martin.
One comment here, so I'm not sure if that's the case, but maybe device classes names are specific to resource flavor. So I could imagine a situation when on one flavor the device class name has name A and the same type of generic resources on some other resource flavor has a different class name. They could also be called like shared GPUs. However, the actual mapping from shared GPUs to a device class could be resource flavor specific. And having like a single object which defines what shared GPU is could be somewhat problematic. Is that the case, Alai?
Actually, this point takes me to a problematic scenario that I have with this particular design. And
Mhm.
if I know Mikhail has additional thoughts, but to continue this discussion, if I can present that problematic scenario, I think that will help clarify and continue this point that Marcin is raising.
Okay, okay. So maybe let's see what the problems are, because maybe we are advising something stupid. So show us the problem, and then maybe like we could make better decisions.
Yeah, it is perfectly in line to what you were thinking. So here is the problematic scenario. So let's assume that cluster admin has defined a resource flavor, fancy flavor, and they have defined GPUs as the canonical name, and then they have a device class called gpu.example.com present, right?
Mhm.
Now, something a new user came to the cluster, and the cluster admin had to define a new flavor for it, but by mistake, in this new flavor they added a different canonical name because it is a new version of the GPU, but underneath the hood it is reconciled by the same device class. This is very possible. For example, all the NVIDIA GPUs, whatever versions you have, they are all going to be belonging to gpu.nvidia.com, for example, as the device class, right? So this is a realistic use case. They have new GPUs as the canonical name and the same device class here. And along with that, they have, because this new GPU flavor allows additional sharing mechanisms, they have shared GPUs and then its device class present here, right? Now, considering these two flavors,
Mm.
the cluster queue is defined for GPUs and new GPUs, and a nominal quota has been put in place for both of them. So in this case, what will end up happening is when Q translates the device class, which is available from the workload, into how many devices were requested to count against quota, the device class that Q will get from the workload will be gpus.example.com, right? And then it has to map this device class to the resource flavor and the canonical name. But in this case, you can see that when Q will go ahead and do that mapping to resource flavor and canonical name, it will find out two canonical names that belongs to this particular device class. One is fancy GPU flavor and GPUs, and the other is new GPU flavor and new GPUs. Both of them are distinct resource flavors uh, with different mapping, and that's why Q reconciliation will get confused on it. Marcin, you have your hand raised.
So I'm not entirely sure if it's always like a mistake, the configuration that you presented. So I could imagine that gpu.example.com on a specific machine could actually be new GPUs, and the same device classes provided by other machines could be legacy, all their GPUs with less power. So while I look at this configuration without context, I can imagine scenarios where this is actually well-intended and correct configuration, where on different newer fancy shiny machines, these device classes provide actually something that could be named as a new GPU. It could be a mistake in one situation when someone overlooked it, and these two resource flavor actually point to the very same machines, but it could be like well intended and expected behavior where someone did it on purpose because gpuexample.com on that specific hardware is actually the new shiny greatest 10 times more powerful accelerator than the same thing on the other. I don't know, maybe like
No. Yeah. I mean, regardless of how we ended up in this configuration, what I'm pointing out is the reason why this scenario is problematic in this design is that when queue is accepting the workload for a particular cluster queue, on there will be two inputs that queue needs. One
Mm-hmm.
input is what device class the workload is requesting, right?
Mm-hmm.
So in this case, that input would be gpu.example.com. That's the input number one. The other
Yes.
input would be what um, flavor um, and nominal canonical name should be used to count quota so that whatever is given from input number two is subtracted or added to flavor usage for that, right?
Mm-hmm.
This is where the problem is, where we queue gets gpu.example.com as the input number one, but for input number two, it has two options because there are two flavors defined in this
Mm-hmm.
cluster, and both of them have the device class in their mapping. So how can Q make a decision that what quota to count this particular
Uh,
against?
Q will go through resource flavors one by one and see where it has enough quota. And I can imagine also like why the names is different, because maybe like the price for GPUs on different hardware is different and the quota may be different, although that they will match to the same device class. However, this device class may now mean something different on different machine types. In resource flavor, what you get is also node selector that could point to very different machine types, which again provide different power of GPUs, and quota could be defined in a different way, although like the device class names are the same. One more thing here, the number of resource flavor is usually very limited in the cluster, so it's a bit harder to make mistake here. It's easier to make mistake if you put it into cluster queue, because like there could be like one cluster queue per user, hypothetically. Usually there is no resource flavor per user, so you just have only a handful of resource flavors and possibly hundreds of cluster queues, which could have different definitions. So the likelihood and probability of error in resource flavor is probably smaller than if this thing was uh, placed in cluster queues. And I see correct application of this one. But again, I might be mistaken. There are other hands, so I will shut up and leave the floor to Dave. Maybe he's got a different opinion.
No, I think I'm in violent agreement with you. I mean, this looks to me like a completely sensible configuration. There's two different resource flavors. They both have GPUs. This cluster of queue is allowed to allocate 4 GPUs, 2 from one resource flavor, 2 from the other, and queue will do that.
I no, I think my concern is with the implementation, right? So for example, when Q is figuring out the resource, so a job with one fancy GPU request came in, right?
Mm-hmm.
So Q
Mm-hmm.
knows that I want to count quota for one gpu.example.com. Um, then it looks at the um, cluster queue. In the cluster queue, it finds these two flavors, right? The first
Mm-hmm.
flavor it looks is this fancy GPU flavor. And in that, it finds this GPU defined. It has the gpu.example.com.
Mm-hmm.
So it will count quota against this particular nominal, this particular um, resource flavor and canonical name GPU, right?
Mm-hmm.
This is a buggy corner case because we Q doesn't know yet whether this workload will go towards that fancy new hardware that Martian was referring to, where the new resource flavor is taking place, or it's going to the older version of GPU. But Q
No,
has
it knows because there's a node selector, right? I mean, it's gonna only go to nodes of that flavor.
but
You shouldn't have overlapping resource flavors.
Yeah, that's a problem. Resource flavors should not overlap.
correct. But the problem with this mapping that I see is, how do we identify that the resource flavors are overlapping and stop this problem?
You usually we don't catch it. We expect system administrators to configure resource flavor properly and to pay attention to what node selectors they are mapping, because Q itself could validate it and see if there are conflicting things, but it doesn't. Right now, there is a problem for the system admins if they specify overlapping resource flavor, but that's not specific to DRA. It's like generic problems that we could try to solve as a slightly different effort. So provide alerting to to situations where resource flavor overlap. But in principle, you should assume that in the correct configuration, resource flavors do not overlap.
Okay. I'll just raise one last point, and then I'll let Mihal go for his thoughts. Even so, there was a point raised that Q can find out the correct node where this is going to, because there is a node selector present in the resource flavor. But I don't think that node selector in the resource flavor would be helpful, because Q will only know uh, where the workload is going after the cube scheduler has made a decision, and the quota evaluation happens during admission time, not after scheduling time. So the only way that that node selector is going to be helpful is if Q can see that there are multiple resource flavors that define the same device class, and both of them have different node selector, only allow that configuration to come through, otherwise reject the resource flavor. I think that would be the only way we can realistically restrict it.
I'm not sure if I understand. So the primary reason why we have different resource flavor is that we have two significantly different types of hardware, for which we specify possibly like a different quota. So both of these resource flavors will have generic node selector pointing to that specific hardware, which will be applied before passing the workload to and pods to scheduler to actually provide these DRI resources. So whatever is passed further will get that specific hardware selectors. I don't know, NVIDIA B200 C40 or whatever GPUs. And then a scheduler, when trying to provide DRA resources, will be limited to that specific hardware, and hopefully it will be able to provide the gpu.example.com, but only within this specific set of nodes. And while configuring it, we have some reason to believe that this request will be successful.
Yeah, I agree with that. The problem is that, so what I'm trying to express is that having a node selector and passing it through the workload is for the cube scheduler to figure out the right node to send this
Yeah.
workload for, right?
Mhm. Right, within the specific subgroup of nodes that have that specific hardware.
Perfect. The problem here is I'm going to go back to my terminology, which is second part of the input to calculating quota is figuring out the right resource flavor and the canonical name. And in figuring that out, that node selector is not helpful because so you can see we have a GPU flavor and a new GPU flavor, both of them having different node selectors potentially. Um, having different node selectors is not evaluated in the quota calculation being executed when admitting this workload. So when admitting this workload, Q will look at the device class. It will go through this resource flavor. It will go through canonical name and find the first one or the last one, whatever policy. It will not look at other things in the resource flavor, for example.
Yes, assuming that there is enough quota in that specific resource flavor, Q will map this resource flavor to the workload and admit it with the precise intention of running the workload on that specific type of nodes.
I see. Okay. So once Q
So
has
it's locked. After admission, it is locked, and all pods that are in the workload will get the node selector and will be pointed towards the correct hardware. And I'm not sure if I see the problem here. Maybe someone else who do see the problem could speak up. I think it will work, but maybe I'm mistaken.
No, I think the way you put it will work. If we can assume that there is a resource, there is a node selector that differentiates this particular resource flavor. And once one of them is selected, their node label, node selector will be applied and Q will make sure that the um, workload goes towards the quota that is counted the device class for, it will be perfect. My concern was that workload going to a different quota, but queue counting a different quota. But applying that node selector will make it work. I think. Sorry, Mikhail. I think we've hold you for long enough. You can go ahead.
Sure. Okay, so first of all, thank you for carrying the effort. I think this is super important for Q to support DRA. Regarding this particular configuration, I fully agree with Marcin. I don't see any problem, and I also agree that this is like pre-existing issue, that if you have overlapping resource flavors, then the configuration is screwed up, and we basically put it for now this on administrators to add node selectors that are specific to the resource flavor. However, I'm not sure in case of DRA, if you can have, for example, one node that provides both types of devices. Maybe this is then more problematic. Is it possible that, for example, you have a node and two types of that, because then you wouldn't be able to separate the probably the by node selector. So this is potentially something that I see like problematic, maybe not for day one, but but it might be problematic to support all the use cases of using the array, if the array supports that.
Yeah, as far as I know, there is nothing limiting DRA to not allowing different.
Okay, so in the array, you can potentially have a node, single node that has both types of devices, right?
Yeah. As long as the DRA driver can handle allocating both of those resources, then it is perfectly valid to have it. And I don't see a reason why the driver could not be capable of doing it. So as an example, with the NVIDIA DRA driver, it's not. I think the plan is that the same particular driver will support multiple devices, and its device class would be gpu.example.com. So you can have a heterogeneous set of devices in the node.
Then maybe this is a little bit constraining, like, but do you foresee this like an important use case for to have such nodes, or it's just something that the array? So
Yeah.
I think for this configuration where we separate nodes by node selector, I don't know how we would handle this use case in Q. But on the other hand, I'm not sure if we need more generic model at the cost of complication to support nodes with heterogeneous devices on them.
I agree with that. I think the most common configuration is nodes with homogeneous devices. And also, I think we can capture this particular thought process that there will be a problematic scenario and a corner case that we have not addressed in alpha, because this is going to be an alpha feature. And I think if we get enough feedback that this is problematic case, then maybe we consider this as one of the use case in beta and modify appropriately. I'm not sure if we have the leeway of designing a perfect solution for heterogeneous use case as well, and then delay the alpha, I think.
No, my gut feeling is that not. We go in alpha with the simplest model, and then based on the feedback, we may. And then this will also give everyone opportunity to learn more about the array. So my gut feeling is that we can move ahead with the model like I see here. There was also a question from Yuki about the mapping. I haven't fully understood yet this proposal. I will need to think. But I think, yeah, I like this idea with using resource flavors. My question to Yuki would be to somehow maybe summarize it in a comment, this alternative approach, so that we can all digest it.
Yeah, sure. So I just mentioned about similar mechanism to Q resource transformation feature, So if I understand correctly, our resource transformation feature can translate arbitrary resource name to arbitrary any kind of resource name, right? So can you correct me, Dave?
Yeah, no, it can do that translation. I think the way you might use it in here is you would do an additional transform. Like if you wanted to limit someone to a total number of GPUs, whether they're using it in time sharing or non-time sharing mode, you would take both them, either one, add an additional resource, which is the sort of logical GPU the user is consuming, and give them a quote on that in addition to the other two. Does that make sense?
Yes, makes sense. Thank you. So is this answer for your question, Michal?
Yeah, I understand the feature, but I don't see still how does it relate to the device class names and the support for the array. So I understand the feature in isolation in the use cases that we have had so far and discussed so far, but I'm not sure how it fits into the proposal of supporting the array. And also, maybe even if it works in some cases, I think it's good to have like dedicated API that expresses the intention, even if we can hack support for the array via some APIs that are designed for other purposes. I think it really matters to have something like that really describes well the intention. And what I see here is meeting this expectation to me.
Makes sense.
I understand it slightly differently, like the original comment from Yuki, was that maybe we could do it in Q config instead of in as a separate CRD or resource flavor CRD. So for resource transformation, I believe we have it encoded in qconfig, not as a standalone CRD object. So yes, maybe we could have it also enabled in Q configuration and have it more static. That could be also like an option to have it there instead of doing it, because now we have resource name definition scattered across two places. We have one in qconfig and we have one in resource flavor. And if, God forbid, we have a combination of these two, like we translate information resource name to some DRA name, then it will be in two places. So if I understand correctly, Yuki, that your comment was maybe we could actually move it completely out of etcd and embed it into qconfig and have it completely static. Right?
Yes.
Okay.
So why I recommended static queue configuration approach is currently, so we try to expand the resource flavor and maybe cluster queue or some core resources at alpha level feature, right? So I just wondering if we can start minimize the static solutions before we move to more dynamically resource configuration feature. Yeah, this is just my comment. Yeah.
Or we could do other way around, so move transformation from config to resource flavors. I believe that the reasons why we had it in the first place in the configuration was that we weren't sure about the API, and in config we are much more free to change it between version than with the actual etcd. So it's more of the question, how confident are we with this API, that it is how it is, because while the feature is marked as alpha, it's actually modifying beta object. So if we decided that it is completely stupid and we need to do it other way around, it's not like we can change it. We need to have one beta 2.
Yeah, correct. Yep.
So that could go in two directions. One direction is that we I guess merging it for and having the implementation ready for 0.12 is out of question for a moment, because the release is, I don't know, today, tomorrow, or whatever. But for the next release, we can take a moment and decide whether what we see or hear is kind of future-proof enough so that we can have a dynamic and in resource flavor, or there are still some concerns, comments, whatever, and maybe it would be safer to have it in config in a static way and then possibly graduate it towards a beta object and marking it as a beta. Maybe what we see here in the cap is actually the API for beta, and we should start with alpha fields in the config, and then once we get feedback and this works, then we will move it towards what we see here on the screen. Okay, I will shut up. There are two other hands. Reason, please speak up.
I think
Dave was first, so
Yeah.
go ahead.
Okay. Yeah. So I just say, yeah, that I agree. There's a sort of non-symmetry there between where we define the resource transformation and where we define DRA. And I do think the point about the API is a good one, that maybe the right thing to do is to experiment And in the alpha level, in the configuration where it's static, you have to restart the queue controller to change it, and then evolve towards both of them. And I guess the other point is, I think it's entirely possible that as DRA comes into more play, that the need for the configurable resource transformation could be reduced, and so maybe it goes away, and so maybe it stays in KEG, or it graduates to something that puts them both together and is part of the API. I think all those are possible, but you're right. We want to sort of go gradually, and so if we think there's a use case for alpha where we have a static thing in the configuration, we experiment with it, we figure out what the API should look like. I think that makes a lot of sense. So go ahead, Michal.
Okay, so indeed, I think the reason to put it in the configuration was that we were not sure, or it was like just basically simplicity of the model to put it in the configuration. However, with this putting into configuration, we created already like this asymmetry, like scattering the information in configuration and here. So I think that ultimately we want to have everything in the resource flavor objects. I think this is conceptually where it belongs. It's just that it was simpler for us to go ahead and not to make committal decisions. So that's why, at least in my understanding, we went for the configuration, not that we want to be eventually there. So regarding this new proposal, we basically, if I understand correctly, we have three possibilities. Indeed, put it into configuration as before, the static one. Put it into the resource flavor as proposed currently, or have yet another kind of transformation API, alpha version, which encapsulates both, like the transformation. This was like option discussed there in the past. And the new, for example, the new extension. Out of these three options, okay, I don't have a strong preferences as of now. I understand like that we don't want committal decisions. On the other hand, we want to be probably in the state where we have dynamically and in one place defined, like in the API. And actually, historically, we also chose different approaches because, for example, for topology, we also considered putting topologies into global configuration, but we ended up into extending resource flavor by the reference. So I don't think even when it comes to decisions like that, we were consistent in the past. I think that conceptually, we want to have everything in API, but it's just a matter how we get there. I think it's better to actually extend APIs. Like, okay, again, I'm not like 100%. You can probably try to convince me other way, but my current thinking is that it's better to extend APIs. I know there is a risk that the API is not fully future-proof, but mistakes always happen. Beta is not like, full V1. We already know that we made a lot of mistakes in the API, and we will need to have V1 beta 2. So one more mistake doesn't feel like end of the world, actually, to me. And I think it really reads much better in one place, like here in the screen, rather than jumping between two places. So
I think I have some thoughts that can
Sure.
bring more clarity, or maybe more organized way of thinking about this. So the way I'm thinking about it is that we should be thinking whether this API, this configuration needs to be static or API driven based on what are the requirements for this device class mapping, independent of what uh, extended resource mapping we already have in place. Because like Dave mentioned, with DRA, the need for mapping extended resources could evolve in the future. So thinking about them as separate buckets of requirements could be one way of approaching it. And if I think about that with that framework, then the core question that becomes for DRA is, do we have the pieces to support this in the API? For example, if the objects change or the resource mapping changes, how will queue react to already accounted quota um, for that mapping? Uh, if the answer is that we have a well-defined way to implement this change in resource mapping, then we can go ahead and put it in the API, regardless of the evolution of the mapping feature that could be independent. But if we don't have correct semantic approach of how to handle the change in mapping, then the safer way is to put it statically in the configuration. Let the API evolve for one or two releases, and then once we have more experience and have a better way of putting it into resource flavor API, move it over. That is how I am thinking about the whole problem space. I don't know if it helps um, drive this discussion in one direction or the other.
Yeah, totally. So yeah, that makes sense for all API graduation steps or something. One another thing is this is maybe just a question. So if we can specify dynamic resources mapping in resource flavor, in this case, so uh, uh, so separate resource flavor has same resource canonical name, but each resource name is provided by another or other device class names, right? So in this case, so if we have so something like, so okay, let's say we have a cluster queue with covered resources, and covered resources have GPUs, resource canonical name. In this case, so if fancy GPU flavor provides GPU dot example.com device class name, but new GPUs resource flavor provides new feature device class example.com device class name. So sorry, so I mean, so I'm not sure. So if my understanding correctly, so my question is just so what can I say?
I think
So
I don't
yeah,
mean to interrupt you, but I have gone through this exercise just yesterday of whether it would be problematic or not, and I think I can summarize it. Um, if this does not address your concern, let me know. So I think what you're trying to say is we have two canonical names belonging to different resource flavors, for
yes.
example GPUs, and it provides different device class name, right? Both of them provide different device class name. When a workload comes in, how does Q know which particular canonical name to count this quota against, because both of them are named the same? I don't think this scenario is problematic because the mapping, when the workload comes in queue, happens from device class to the canonical name, not canonical name to device class.
Mhm.
Because we have one is to many relationship uh, between sorry, because we have 1:1 relationship between device class and the canonical name, this situation will work because um, both device classes will resolve into the right flavor slash uh, canonical name mapping. In the case of in the case of new feature device class.example.com, it will be new GPU flavor / shared GPUs. And in the case of gpu.example.com, it will be fancy GPU flavor / GPUs. So we will have the right resolution. The only problematic case is otherwise, where two differently named canonical names provide the same device class, which we discussed earlier, and that I think will be resolved through namespace, node selector. Does that help answer your concern?
Yeah, thank you. So I fully understand your description. Yeah.
I think this is an important point. I will make sure I document this in the design, so future us can refer to this.
Yeah, that makes sense. Yeah.
I know we are edging towards the top of the hour. So if this topic does not have any more thoughts, I wanted to address one of other Marcin's feedback. So before I move into that new context, I just want to give a moment for folks to add additional thoughts or conclude this topic.
I only have one question. Are you going to fit in within the next 5 minutes?
Yes.
Okay.
Yes, pretty sure. Okay, so the other question that Marcin had last time was, how does DRA API react on changes? So for example, when the workload is admitted, what happens before the admission and workload actually running and allocating those devices? If the requests change, what happens to quota calculation? So I went back and looked at all of the DRA APIs, and here is my summary. The resource claim template is immutable. The resource claim is immutable. So once these two objects are created, they cannot be changed. So if we want to track what was saved during quota calculation, we can use the objects UUID as things to track. If that changes, that means these objects were deleted and recreated. That was my conclusion number one. And the other is that device class is another API that can change. It is mutable. However, it has a generation number that gets updated every time the spec changes. So Q can save the generation number when it evaluated quota. And if that changed, that means quota has been, configuration has been changed. We need to reevaluate quota. So for all the three APIs, we have a way to find out if it was changed or not. Yeah, Marcin, go ahead.
So I'm not afraid of any system or administrator-owned object being changed. So device, class, or whatever changes are not a problem. The only thought that I was worried is resource claim, but as far as I understand from the CAP, we will have the actual number mentioned in this status section of the workload. So the number is there and we don't need to worry about resource claim being changed because we have the previous number, and if it changed, the workload will be stopped and we will recreate it.
Perfect.
So from that perspective, we are good, and changes in system admin objects are not a concern because we trust administrators to do the right thing, and if they decided to shoot themselves in the foot, so be it. It's just that a user should not be able to Regular users should not be able to game the system, and I believe that what you wrote, this is not a threat.
Okay, perfect. Thank you. All I wanted to say is we can get even more granular. There are options where along with the count, we can save the UUID of that object that gave us the count. So anything else apart from the count changes, Q will be able to figure it out. But I don't think, but what I'm hearing is that is not needed, at least as of alpha. So we can save that for future.
No, just the count, at
Yeah.
least in my opinion.
Got it. Okay, I think that's all.
Literally right on time. Thank you very much, Ale, and everyone else for the discussion, and hope to see you next time. Bye,
Yeah.
all.
Bye. Thanks, everyone.